In this video, we're testing one of the wackiest things I've ever seen. A biplane, cargo, double wing, 8-motored monstrosity, bigger than the Super Guppy. This is the Howard DBA. So what is the Howard DBA? Well, if you had a Super Guppy, which is this airplane many people have already built RC models of, and made it bigger, i.e. stung it 1,000 times by a beat, this is what you would end up with. This is originally like a 1960s concept designed to move Saturn rocket parts. It was designed, and supposedly there's an RC model of this thing, but I've only found this picture of this model in the wind tunnel, and it was supposedly aerodynamically sound. We're going to build the Howard DBA. So I know how I want to build this plane, but I don't want to 3D print this thing because it's just too big to fit in a printer, and I just think it would be just too heavy and too much plastic. So I'm going to use a hybrid method. First, I'm going to beat my head over this keyboard until I get this model. Alright, I'm drawing my airplane in Fusion 360, which has basically been my go-to forever, but it really sucks because I've designed these flat shapes that are designed to be folded out, but there's no fold feature in this software. It seems like for $600 that you have to pay every single year that this software should do this, but I'm not really impressed with Autodesk anymore. So I have to go online, use a different CAD program called Onshape that actually can natively do this, and I can flatten my shape with the simple clicks, and boom, we have this three-dimensional shape, flatten it out for 2D cutting, and then I can cut all this stuff out. Look at it. It's so cool. I've never designed an airplane like this where it actually worked out. Like, this is a first for me, designing a very complex 3D fuselage. Boy, do the results look pretty good. You just roll the foam. We're making it out of this pink stuff because it has the skin on one side, which makes it easy to fold. And then we just crush the inside here. And then we put all the sheets on, and then we have an airplane. So this plane is definitely different for me. As you can see, it's actually going pretty well, but I learned from some of the greats, mainly John Overstreet. He builds planes like these all the time with these intricate sculpts. I have no idea how he does it, but I finally got this to work in CAD, and I'm super excited to build some other weird shaped airplanes because, well, this is actually a pretty efficient way to build an airplane. Even though we've kind of used up a lot of sheets of foam, it's definitely not as bad as printing them out of PLA, which this would have probably taken over a week. And for the wings, we're going to hotwire some Clark Y profiles using my latest and greatest hotwire foam cutter because I want some more accurate airfoils. Now this project, it's a lot of cutting, a lot of design on the computer, and a lot of 3D printing. However, if you didn't have these machines at home, you could use our sponsor for this video, PCBWay. PCBWay specializes in making printed circuit boards. However, if you didn't know, they do so much more than just PCBs. PCBWay can CNC aluminum, such as these giant brackets from my past boat project, injection molding. They even cut carbon fiber from the last video, as you can see with these sick carbon fiber plates. I even used PCBWay to print these giant parts for my lobster boat video a few videos back. This project obviously has a lot of giant parts, such as these giant 3D printed clamshell doors for the front of the airplane. If you don't have a printer that's this large, you could literally just send it to PCBWay. It's super easy. You just upload your design files to the website, get an instant quote, pay for it, and then in a week or two, boom, your parts show up at your doorstep. They really make it easy to make all these projects possible because I don't have to deal with machining these things myself. And if you're interested in making giant parts like this airplane, but for your own unique projects, use PCBWay Peter Sheeple 10 to get $10 off orders over $30 or more. The code is in the description down below, so be sure to check out PCBWay. Anyways, we got a plane to finish. It's alive! Got that differential throttle. That is actually backwards right now. Hey, it's got as many motors as the Spruce Goose. It's got a little bit of thrust. Alright, this biplane monstrosity certainly looks interesting. I honestly don't know if this is going to fly myself, but AirShaper contacted me and they wanted to run this thing through a simulation. So here we have Howard DBA, and boy, look at that. But it's like swirling off the back of the fuselage, which is kind of crazy looking if you look here. It's also pretty neat. Like, you can see how the airflow is following the teardrop shape of the fuselage. Now, because it's kind of like an airfoil shape, I think this might be kind of causing the fuselage to naturally rise up. So maybe I can get away with a slightly more nose-heavy configuration when we fly it. But I don't know. This is a simulation, so I don't know if it's actually going to behave in real life. What's cool, too, is it even has drag coefficients. So it's actually pretty good. The airplane's got 0.056 drag coefficient. A sedan is worse, a Sphere is worse, and a truck is worse, and a cube is worse. So we're pretty much in line with the teardrop. Generally, if you look at the fuselage, it's a teardrop shape. So basically, it's giving me a lift-drag ratio, too. So this is an L/D of 3.5. Now, for context, a C-130, which is another cargo plane, according to the AI slop that's being generated by Google, it says it's a 9.1 to 12.1. But honestly, a C-130 is much more clean of a fuselage. It looks more efficient. So this plane's pretty bad, but it should be flyable. It's not the worst thing in the world. All right, check this out. This is the coolest part. I took it one step further. Rather than just making model of the airplane, it actually functions and the face opens up. Or actually, its pregnant belly opens up. Well, unfortunately, I'm not really able to fly it right now because, let's say me and my lovely woman are having a baby. So this plane is the perfect vessel for the gender reveal. So we had a little get together and... would you look at that? It's a boy! The blue airplane's a boy. But I would normally probably test this airplane before we paint it and all this stuff. So I have a lot of time invested in this airplane so far, and I really don't know if this vertical tail grouping is good enough. We've done the simulation to see how airflow flows around it, but I don't really know if this plane is actually stable. So inside the airplane, we have the small airplane. And if you wonder why I did this, is because, well, air is a fluid, water is a fluid, fluid simulation. If we have the small model, I can assess whether this tail grouping and volume is actually enough for a stable airplane. So I basically balance this exactly as we would the real airplane. It's obviously not going to fly in the air, but if we put it in water, it should fly like the real one, and it should be stable. This should tell me if the tail grouping is right, if the plane falls in a straight line. That means I'll know that this plane will fly fine. It looks like it flies. Now, it's definitely draggy. It doesn't go very far before it slows down too much, so that's part of the design. I would be satisfied that this was a glider and it flew like that. To show you basically what I'm testing here, so we know it flies good because it tracks in a straight line. But if the tail volume was a little bit too small, and we try it, it'll skid out, which is what I'm looking for. Alright, this plane is complete. I have actually kind of a lot of time wrapped up in this thing so far, so I hate to crack it up. Let's go to this big parking lot where I have all this runway in the world, and let's try to fly this puppy. This pregnant super guppy. Pregnant puppy super guppy. I do have to say, as we're taxiing this plane around, no one has really seen the real-life model of this. Supposedly, there was an RC model built of this thing. There's no pictures, no videos, no nothing of it, and I think that was built in the 90s from what I could find. So that has me thinking, maybe this plane cannot actually fly. Let's firewall the throttles. It does fly, okay. That wasn't too bad. Okay, it's underpowered. This is basically running on 2-cell, and these are really tiny propellers, so 2 cells, 7.4 volts. Not enough power. Let's go back to the shop, grab some bigger batteries, and head to the field again. Have you seen the really big one anywhere around here? No, not that big one. That big one.
Who did it bigger?
Alright, we got a bigger battery in the plane. More voltage, basically. So it should fly. The plane barely flew, and it was pretty stable-ish. So I'm going to give her the beans and see what she really can do. Alright, you ready? Did not get off the ground before it was not the best handling airplane, I'll give it that. Here we go. Okay, she flies. Hey, that's not bad at all. I'm coming off the throttle too. Perfectly airborne. Okay, it's a little side slippy, like the rudder wants to slide out. So maybe it needs a slightly larger rudder. But it flies like a fat pig. Not that I know what a fat pig fly is like. It feels a little tail heavy, even though I know it's a little front heavy. It's really weird flying this. It's like, it flies straight for a minute, and then it starts really side slipping, and it tries to enter a spin. Should I see if she can do any aerobatics? All right, I'm gonna climb up high. I don't think it's gonna do loops. It needs a lot of pilot input to stay steady. I tried to glide it to see what happened, and it's basically gonna crash. It's a very terrible flying airplane. Setting up for the approach. And we lost all the wheels. All right, this thing flies not beautifully at all. Actually flies pretty bad. Now that I've really had some stick time with it, trying to go in a straight line, you think it's good, but it starts really wandering, and you try to just use ailerons to do it. Then you're starting to add a whole bunch of rudder, and it's still like skirting, and all of a sudden it snaps over, goes the other way you want it to, and then it looks like it's going great. And next thing it starts fishtailing around, and it's this constant battle using a lot of motor differential input and rudder. I have a feeling that if I did not do this differential throttle, that this plane would have probably crashed by now, because I think the rudder surface is pretty inadequate for its size. And mind you, when I designed this model, I made it like 10% larger than the actual 3D drawings I found. So I have really no idea what they're talking about when they said this thing was a model built at some point and flew. Couldn't find any videos or pictures of it, probably for a reason. Now, the fun thing, I'm going to go ahead and add some extra vertical stabilizers to it, and then we're going to try to open up the face in flight, because I know you guys are probably wondering, we've had RC cargo planes with the back doors that open up, and that's just like, you know, opening up your trunk on the freeway. This is like opening up your hood on the freeway, and we're going to see what it does to this big old weird airplane, but I know we're going to need some more vertical stabilizers. We've got the actuators reinstalled, because now they know the plane flies. I don't have to break these because they're kind of expensive and hard to find, and we also have the bigger tails. So let's take this thing out for a quick flight and make sure it works. And then we'll see if the plane can give birth mid-flight. Oh, that's so much better. Okay, so the stabilizers make it track much smoother. It looks good in the air. I think we can fly this. Okay, I'm gonna go on land. Oh. Okay, let's see. Will it work? Let's find out. I'm gonna quickly climb. Just gonna keep climbing. Probably the second go around, I'm just gonna open it. Need time to recover, because the doors take 4 seconds to open.
Oh, I don't know how to fly backwards in front of you.
Oh, no.
So did it just die?
It just died.
Okay, ready? I'm opening the doors.
Oh man.
Try to keep flying. All right, fly. Go. Full power. Okay, I'm losing altitude. I'm trying to close. Come on, close your face. We're gonna crash. Oh no.
Oh, I don't know how to bring it down. Oh, here it comes. Oh.
Okay, so the aero drag was too much for the airplane, and it could not close its face. But hey, the plane came out.
Oh, not into the lines, not into the lines. Oh my God!
Over here.
Oh, no.
More power, more power. Throttle, throttle. There we go. Okay. Now come this way.
Get it.
Try again.
Baby, catch the real baby better. Oh.
Oh no. It gave birth, but at what cost? The actuators are closed, but I think something got tweaked. We'll have to look on the footage. Fortunately, we have footage. I hope this thing is still recording. It's still recording. The actuators are all in the closed and lock position, but the aero drag was just too much, and it was just like a slow, well, not really slow, but pretty aggressive decel, and then crash. Oh no! The air is actually pretty strong. There's normally a seam, and I can see like clamping the doors shut. It's interesting the actuators had enough power to open them, but yeah, I want to see what happens when I try to close them. Open sesame. Oh yeah, I think it slammed open. The little plane goes. That was great.
Well, it's like going down. It's going down fast.
That did not last long.
That's what she said.
Yeah, it's basically like I'm opening up, and it's like I cried open completely. But honestly, I think the plane is probably fixable. It's just a little cracked here, and I would have to reprint the front part. But the top face is still good. We probably could just repair it. So what did we learn today? The Howard damn big airplane. It indeed does fly. But if you open the front doors in flight and give birth, the plane doesn't do so hot. Also, we learned it's a boy today.
It's a boy.
I'm trying to kill you. You can turn that off. This flew out like nobody's business.
Yeah, let's just use your hair. Oh. Hey, there's skin to skin time.